graph. Feel better?
Yeah.
Can't hit your heart yesterday. All right, let's do the top one first. Y equals 2/3 x minus 2. If I was going to graph those two, or graph that line, yeah. Huh?
Could I go use the bathroom?
That's fine. First thing is we got to decide where we're going to start at. Okay, so if I graph y equals 2/3 x minus 2, where am I going to start at? -2 on what? The y-axis, okay? And even after talking about this yesterday, okay, probably one of the most missed things when we graph this is I still saw a few people yesterday trying to put the -2 on the x-axis, okay? It's not the x-intercept, it's the y-intercept. So you got to be completely sure about where you place that point, because it's a completely different place, right? On the y-axis is where it belongs. The second thing is once I place that y-intercept, this is my slope. And what we talked about yesterday, slope is rise over run. So from this point, we're going to go up to over 3, and we're going to make a point. Okay? I could do that as many times as I want. I could also go down 2 and left 3. Okay? Now, do I need that many points? Probably not, right? But I'm just showing you that if you wanted to continue the line, and sometimes there are times where I want the line to go down here further or whatever just to see where it's going to end up, then it might be helpful to be able to continue that line. Okay? And then if I really wanted to be exact with where I connected my points, I connect all those points together. And it should make a line, okay? We said yesterday, if it makes some other type of graph, then we've done something wrong. It should always make a line. Okay, on the next one, we're going to start at 3. This is our y-intercept. So we're going to go up 3. And then from that point, we're going to go down 4, because our slope is -4 over 3. So we're going to go down 4 over 3. And once again, you could do that as many times as you want. I could also go up 4 and left 3, but all we really need is 2 points. And there is not the best line, but we get the idea. Okay, before we get into what we're going to talk about today, parallel and perpendicular are going to be two things that we're really going to focus on today. Okay? And if we talk about parallel, what do we know, or how do we know if two lines are parallel to one another? Okay, sometimes it's the markings, right? It has the arrow on it. Yep. Okay. If I'm graphing on a coordinate plane, what would be true about these two lines if they were parallel? What would they have to have? They don't intersect, right? And so what would, in order to not intersect, what would the slopes have to be? Equal. Yeah. So if this one has a slope of 2/3 and this one has a slope of 2/3, then those two lines are going to keep going up and over by the same amount, and they are never going to cross. Okay? Their starting point would be different, but they're just going to keep going and never cross one another. Okay? That's what would make them parallel. Perpendicular is another word that we've talked a lot about so far this year. Okay? But now we're seeing it on a coordinate plane, and today we're going to see it on a coordinate plane. And in order for these two lines to be perpendicular, not only do they intersect, but where they intersect has to be what? What do they have to form when they intersect? A right angle. Okay, they have to make a right angle. Now, when I look at this, do I know for sure if it's a right angle or not? Does it look like it could be, maybe? Maybe, possibly, okay? They do intersect, but we want to figure out, do they intersect at a right angle, okay? So here's what I'm going to tell you, and I'm just going to go ahead and talk about this right now while we're here. In order for these two to be perpendicular, the two slopes must be opposite and reciprocals. We have to do the opposite and we have to flip it over. And so the saying that I use that goes along with that is we must flip the switch. Okay, and all that means is we're going to do two things. We're going to take 2 over 3 and we would flip it over, which becomes 3 over 2. And then we're going to switch the sign. So if I said 2 over 3 was my original slope, the perpendicular slope would be negative 3 over 2. Okay. I'm going to flip it over and I'm going to switch the sign. So these two are definitely not perpendicular. They're close, right? But not perpendicular. And that's how we would determine. We can't just tell necessarily by looking. Is it 90? Is it not 90? I'm not going to ask you to get a protractor out and measure the angle and see what the angle is, okay? We're just going to look at the slopes, and the slopes will tell us everything that we need to know. Okay, what is the equation for a vertical line that goes through the point negative 1, 4? Okay, goes through the point negative 1, 4. So first of all, let's graph that point. There's negative 1, 4. Hannah?
X equals negative 1.
X equals negative 1. Because what we're going to do is we're going to draw a vertical line that goes through that ordered pair. And what we said yesterday was it's only going to cross the x-axis, right? It only crosses the x-axis at negative 1. It will never cross the y-axis. So there's no y in our equation. And so our vertical line here would just simply be x equals negative 1. That's all we have to do, okay? We can't really put it in slope-intercept form, and the reason we can't put this in slope-intercept form is we talked about this a little bit yesterday. What's the slope of a vertical line? Undefined, okay? And so here, our slope is undefined, okay? And so we can't put it in to y equals mx plus b because it would look something like this. Y equals undefined x plus b. We don't even have a b, right? So we don't have a slope and we don't have a y-intercept. How in the heck would we put that in slope-intercept form? We can't, right? And so when it doesn't have a y-intercept and when our slope is undefined, we have to have a different way of writing the equation. So in this case, we say x equals negative 1, and that's our equation. So it's pretty straightforward. We're always going to use the x value to write that equation, okay? And if you want to graph it, you can graph it. Like there is a graph right here, but you should be able to do it even without graphing it too. Okay, if we graphed the point 5, 3, and we made a horizontal line, make sure you understand the difference between horizontal and vertical, okay? This time, it only crosses the y-axis. So when we write this equation, it's never going to cross the x, so we don't want an x in our equation. And so here our equation would be y equals 3. Some people would do this because the slope of this equation is 0. So some people would be 0x plus 3. But is there any reason to put 0x in here? No, not really, right? Because 0x is really just 0. And so we can just eliminate the 0x part, and we can just say y equals 3. It's not necessarily wrong to write this. It's just not really needed because it's 0, okay? If it's any other number, then obviously we would need to include it. But 0 is different than any other number. So we can just leave it out. All right, so today what we're going to talk about is, and we already have kind of done this, right? So this will kind of be just a repeat here because we talked about it on the front page already. The slopes of parallel lines. If we're graphing it on a coordinate plane, like Adrian said earlier, these two maybe have an arrow on it, okay? Maybe they do, maybe they don't. But in this case, they both have an arrow on it to show that they're parallel, okay? And so we know that they're parallel. And we already talked about what the slopes have to be, right? What did we say the slopes would have to be in order for these two to be parallel to one another? They have to be equal. The slopes must be equal. Okay, if this one is 3/4, this one's got to be 3/4. If this one's -5/2, this one's got to be -5/2. We will have positive slopes and negative slopes. If this one's vertical, then this one's vertical. Okay, if this one's horizontal, this one's horizontal. Those are all examples of parallel lines. They all have the same slope. Even if it's undefined. Okay, even if it's undefined. Okay, and then we already talked about perpendicular. They will make or be opposite reciprocals of one another. So if I gave you a slope of 5/3 and I ask for the perpendicular slope of 5/3, we have to do two things to 5/3. What would be the first thing I'm going to do? Flip it over. Okay, so 5/3 becomes 3/5. And if the first one's positive, this one has to be negative. If this one was negative, this one would have to be positive. Okay? And they have to be opposites. Opposite means one's positive, one's negative. It doesn't matter which one's which. Opposite signs. And so once again, I will put that here. If you can remember this little saying, it tells you what you have to do. Flip the switch. Okay? No, she can sit at my desk if you want. Or there. Yeah, either way. Yeah. Okay, so flip the switch is just a quick and easy way that I can remember to do it. Okay, flip it tells us to flip it over. Switch means switch the sign. So if you can remember that little quick thing. Okay. Now here's another thing that we always say about perpendicular slopes. If I were to take 5/3 times -3/5. If I were to multiply those two together, let's see what happens. 5 times -3 would be -15. 3 times +5 would be a +15. So this is -15 over +15. But if I reduce that, what's it end up being? -1. Okay. So when I multiply two slopes together, they will always make a product of -1 every time. Okay? And so we know that to be true. and one of the main reasons why we talk about this is a pretty good like ACT type question. Whenever you take the ACT or the state assessment, that's one of the pieces of information that it'll always say about perpendicular slope. And so that's just kind of something you need to keep in the back of your mind. If I were to multiply them together, they will always make a -1. All right, last thing that we're going to do today is we're going to try to determine, looking at all of the lines in this picture, and it looks like a pretty big mess, right? But we got 4 different lines in here, A, B, C, and D. We want to find the slope of each one, and then we're going to compare the slopes of each one, okay? Now, the nice thing about this is that we have a graph, okay? And the fact that we have a graph makes, I think, finding the slope a little bit easier. We talked about this a little bit yesterday. If I want to find the slope, I can simply use rise over run. And if I'm given a graph, that's going to be my go-to. That's what I'm going to use to find my slope. I don't have to use, see ya, good luck today. I don't have to use the slope formula. I mean, if you want to use the slope formula, you can, okay? But we would have to do it 4 times, okay? And I would say that would be a lot more work than what we need to do. So if I go to line A, first of all, I'm going to locate 2 points that are on line A. And what we're going to do is we're going to go, I always go left to right, okay? And it really doesn't matter. I mean, if you started at the point on the right, and you could come back to the point on the left, but just like we read a book, we want to go left to right. So I'm going to go from this point to this point. And sometimes there may be more than 2 points on that line. So you can pick any 2 points you want to, as long as it crosses through one of those order pairs exactly. So we're going to start here. We're going to go up 1. We're going to go over 1, 2, 3. So our slope here, pretty simply, is up 1 over 3. Okay? Doesn't take me much time to get there. Much easier than having to go through the slope formula. If I wasn't given the graph, I may have to do the slope formula. Okay? But I don't necessarily need to do that here. Okay, line B, they're all labeled right here. We're looking at the red one. So we're going to go from here to here. We're going to go up 1 over 2. So our slope would be 1 over 2. For C, C is the green one down here. We're going to go from here to here. So we're going to go up 1 over 2. And finally, D, the one thing you'll notice about D is going down as it goes to the right. So what's that tell me about my slope immediately? It's got to be negative, right? All of these are moving up as they go to the right. This one's going down. So this is going to have a negative slope. So your answer should be negative here. Here you have a couple of different points that you could use, but I'm just going to use these 2 because those are the 2 that are labeled. And we're going to go down 2 and over 1. And that would be our slope for D. Okay, those are our 4 slopes. Now we're going to use those slopes to help us identify, are any of these parallel, are any of them perpendicular? Okay, so do we have any slopes here that are the same? B and C. So we would simply say here B is parallel to C. And we can use our symbols. Okay, parallel is just 2 lines right next to each other. It means parallel. Okay, those are the only 2 lines that are parallel. Okay, then we'll go to perpendicular. Are there any lines here that are perpendicular? Okay, C and D. Okay, so I can say C, and then what's the symbol that we use for perpendicular? Upside down T. Okay, C is perpendicular to D. Is that it? Yeah, and B and D also. Good. Okay, because we said B and C were parallel, then both of those would be perpendicular to D. That's one of those theorems that we talked about just the other day. If 2 lines are parallel to each other, then they're perpendicular to the same line. And so that's what we're using there. Okay, questions on that? Okay. Last one. A, B, C, and D. A, B, and C all have a positive slope. D has a negative slope. Okay? Then we got to find the actual number, what the actual value would be. So A is the blue one here. If I'm going to go from point to point, always do rise first. So we're going to go up 1, 2, 3, 4, and we're going to go over 2. Now, one of the things that's important to note here is if we can reduce it, we'll reduce it. Okay? If it doesn't reduce, like the ones on the left that we did, none of those reduced, right? And so we just left them as is. For part B, and it's not wrong to write it as 2 over 1, but we don't really need to write it as 2 over 1 unless it helps you when we start comparing. But just remember 2 and 2 over 1 are the same thing. Okay, for the line B, for the red one here, we're going to go up 1, 2, 3, 4 over 2. So that one is 4 over 2 again, which is 2. Okay, line C is the green one here. So we're going to go up 1, 2, 3 over 1. And finally, line D is the purple one. Here's the 2 points that they have labeled. Those would be the 2 points that I would use in this case. So I'm going to go down 1, right 3. Really watch your signs. When I go down 1, that's negative, right? Going down is negative, going left is negative. Going right is positive, going up is positive. Okay, so this does not reduce, so that would be my slope. And then the last thing that we're going to do is we're going to use those numbers, those values, those slopes to determine if these are parallel or perpendicular. Parallel should be a piece of cake, guys. We're looking for any of these that are the same. Right? Do we have any that are the same? Yeah, A and B, right? So once again, we say A is parallel to B. A. And then, do we have any that are perpendicular? C and D. Yep. C is perpendicular to D. Okay. And then that would be it. Those are our parallel and those are our perpendicular. Okay, we split this up into 2 days because there's a lot of stuff in this section. And so tomorrow we'll continue talking about parallel, perpendicular. I will tell you on your homework today,